So we'll start with different methods which are required for this load forecasting. So I will have name of this is load forecasting methods. Okay, so we'll see these different techniques or mathematical approaches for this load forecasting. So mathematical models means what? We have different approaches. So first is probabilistic method, second is stochastic approach, third one is deterministic approach. Okay, so all these are what? These are all different approaches. So one by one we will see. So general block diagram for load forecasting, you know how it is. I will first list down all the approaches, but before that I'll draw a very basic diagram, or we can say steps how we can proceed for load forecasting one by one. Is it clear? So I'll draw first box. First box, and in that I will write data collection. This is first step in any of the load forecasting method. After this step we go to second block. What is second block? Second box is we have proper model selection. So we have to select a proper model, just like in the case of weather we have selected a weather load model. Then we have third box. Okay, this third box we have identification and updating. Identification and updating model parameters. Okay, so different parameters we have seen parameters earlier. So modification of that and updating we do, and last, or we can say second last, is your testing or forecast. Is our forecast correct? So we should test it once. And last is what? Last factor here is if error exists, you have to go to step 3. What is step 3? This step. So you have to go here from here. Okay, or else you can, if there is no error, you can stop. So this is a very small, we can say, algorithm. How do we write algorithm? A box, then we write start, then like this. So what is first step? Data collection, then proper model selection, identification and updating a model parameter, testing, and if our model works well, we'll go ahead. So that is stop. Whenever we say stop, we have to stop our process. Got it? So this is how we can model. So for load forecasting we use various parameters. So what are these parameters? So I'll note down one by one. So first parameter is peak load demand. Peak load demand is first parameter. What is second parameter? Energy demand. Then what is third parameter? Total load. What is fourth parameter? Use of average or use of average or extreme condition load. And fifth one is time period. Got it. So all these 5 parameters, these are there. So there are many parameters you can add to this as a load forecaster if you have any. Okay, now we'll directly move to methods. So mathematical methods. So first method, you know this method, you've done it already. It's called extrapolation method. Second method is correlation. This is double R. Correlation. Okay. Then third method is linear regression model. And fourth method is trend projection. Method. Okay, so you have to write method in front of everyone, or either it is a method or it is a model. Okay. Fifth one is semi-parameter additive model. Additive model. Then sixth one is ANN model. What does it stand for? Artificial neural network. Then seventh one is univariate model. Eighth one is similar day method. So what happened on the same day this month last year? Hierarchical forecasting method. And 10th one is time series method, very popular method in data science nowadays. And last one is expert system method. So there are many, I can write etc. again for this, all these methods. Out of this we are going to see a very few. So these are again divided into, as I said, they are deterministic, probabilistic approaches. So if you try to find out in 1960, and right in front of every method what timeline they were developed. So methods used, so time series is very old method. Before that we had this method, extrapolation. This is 1960s. This time series method started in 1970. Then we have in 1980 we had correlation. Then linear regression and all these are in around 1985 and all. Then we have semi-parameter additive model, this method. Some of them which I know I can write here. It is 1990. Then for hierarchical forecasting method it is 2010, and latest today we have this method. Draw again. It's a very popular method nowadays. This is some kind of, we can say, evolutionary algorithm. Oligos. So this evolutionary means what? They are some kind of similarity they find out, and how others work depending upon that your methods are developed. So we'll not go deep into it. We just want to see some kind of examples. I will give you quick examples of this. Let us start with first method. So all methods are not in syllabus, this expert system and all. We have extrapolation method. This is first method, extrapolation. So now what this method does, so what you can do is, if you have a data points like this all scattered here, so what you can do, you cannot join all the data points as you want. This is the wrong way of joining, this is wrong. Then if you try to join this like this is wrong. On y and x axis, if you are trying to draw this might prove you wrong, correct? So what you can do is, you have to find out a line in between all this. This is a line which is covering major points. How you have to draw this line? It will cover major points, and second point is, it will be near to most of other missed points. Getting the thing? So these two should be covered. So distance between this and this is very near. This is covered, this is covered, this is covered, some of these are covered, correct? Then you have to see the distance. These nearer points are covered, this is covered, this is covered. If you draw a line like this may not cover these points. If you draw a line like this may not cover this point. So median line which covers all the points and passes through most of the points is your line. So this is called curve fitting. So we fit all the trend curves to historical data to represent their trend growth. This method gives accuracy for forecasted value. So commonly used analytical functions are, so how you can write this equation for this? Equation for this can either be written as y equal to a plus bx. This is one way of writing. So if this is not a line, say if you have a parabola, how you can write this? That means parabola will cover what? There are more points here than these points, and there are more points here, here and here. So how this line will, instead of a straight line like this, it will be a parabola, correct? So this is your parabola. So how you can write this? Y equal to c e raised to dx. So this parabola is represented by a exponential curve like this. This is exponential curve, and this is your c intercept. this is again a is again this value a, getting the thing. So all this is what is your curve fitting technique. Third curve fitting technique is y equal to a plus bx plus cx squared. This is called as quadratic. I will write in front of it, this is straight line, this is exponential, this is quadratic, or you can say parabolic, and last one y equal to a plus bx plus cx square plus dx cube. This is called as, right here, polynomial. This is polynomial. So all these are called as extrapolation method. You can also have a conic method, you can have deterministic extrapolation. So there are no attempts to calculate your errors. So you have to find out good accuracy and draw a line in between. So we'll go to next method. Next method is called as, second method is correlation. So now what is this correlation? Correlation forecasting method is associated with various demographic and economic factors. So all economic demographic factors are correlated. So interrelationship between growth, load growth pattern and other factors can be easily calculated. Correlation means what? You have to find a relation, you have to find a nearer function. More commonly used factors are what? Population, then job, building permits, equipment, business indicators, weather data, etc. So there are two types of correlation. So first correlation is either a positive or negative correlation. This is first correlation, and second correlation is linear or non-linear correlation. If the values of two variables changes in same direction, if they change in same direction, if increase in one variable leads to increase in other, this correlation is said to be positive. If correlation between two variables, when it is said negative, when one variable increases, right, one variable increases, other also increases, one increases, other decreases, it is negative correlation. Got it? So how you can draw, I will show you on a graph what is positive and what is negative. This is your graph. So perfect linear correlation means all the points are in a straight line and you are joining all this through a straight line. This is a perfect correlation. So this correlation R is given by value 1. Okay, then comes next is negative. Negative means what? The data points you are getting like this, you join this through a straight line. This R is again 1, but because of slope like this, it is -1. So this is called as positive, this is called as negative correlation. Okay, we'll move to next blank slide. Okay, then correlation coefficient is given by what? R. So this R is 1, this is positive, and R is -1, it is negative. Then say if there is a graph and all the points are scattered like this, and they are far away from each other. These are all data points, they are not in a straight line. So this type of correlation R is 0. That means there is no correlation. Normally if R value lies less than 0.1, we said that it is no correlation, there is no relation between any points. So scattered diagram is like that. Then we have a positive correlation, but we have scattered values. They are within some range, but they are scattered. So now you cannot draw a line from here or here, you have to draw a line in between these 2 points. Getting the thing? So this covers what? This covers both the points. So here your R value ranges from 0 to 1. So this is called as positive correlation. If this diagram scatters like this, so this same diagram you can take, but scattering is also within a bounded region. This region you have got scattered points, so this we called as weak positive correlation. Similarly, if there is scattering in some region like this, but in negative direction, it is called as weak negative correlation. What is the value of R here? R will range from -1 to 0. Here it will range from 0 to 1, and so on. So all these are different types of correlation. Ideal or perfect condition is when R is equal to 1, that is a straight line and it has got maximum points on the line. Let us go to third method. It is called as linear regression model method. So regression analysis is a statistical process, and for getting relation among variables we have short term load forecasting and long term load forecasting. So we have STLF and long term load forecasting. These two methods. Here load is taken as dependent variable, while weather variables are treated as independent variable. So this is just for your information. Name of this is, this name we have discussed third method, linear regression model method. Then we have trend projection method, fourth one. Trend projection method. So what we have in this trend projection method? We have a basic trend like this. Then we have seasonal trend like this. Then we have third is random fluctuations, and we can draw a straight line like this. So all this representation is for trend line. So this is time, not load. And what is changing? This is what we can write here is basic trend. This is seasonal variation, and last is random fluctuation. So here trend curves are fitted to get variational axis of load growth. So you can see different trends how they are fit. Basic trend there is no need, but seasonal and variation. So you have to watch for a trend. So I will just give you an example of this. So your this curve may be like this, a straight line, okay? It may be like this, variation is like this. So how will be a trend line? Trend line will be, this will be trend line. So this is increasing, see, it's not straight line, it is increasing. So what is prediction? That look at this diagram, that your variation lies within this range. So what will be next? This is next as a load forecaster. Sorry, go to 6th slide, right? I'm showing you, this will be your next output. Got it? Let us go to 5th method. 5th method is semi-parameter additive model method. So this is again nothing but regression model involving non-linear relationship with a measure to accommodate your correlated errors. In load forecasting, these additive methods are used for to get relationship between load and your variables like temperature and load, or seasonal variation and load, demographic, economic factors and your load and all. So this is not that important. I will just write down the name, semi parameter. Not asked in exam, just whenever there is question you should write this in your answer and write 1 or 2 lines on this. Okay, let us go to 6th one, is ANN. So what is artificial neural network? So since 1990 it is being used, and this is very good for soft computing. That is, you can use computer as a model. Any non-linear mathematical model can be used. So what you have input here, you have hidden layers here, and you have output here. So 1 to n I have output. Inputs are configured to these layers and outputs are configured here. So depending upon your historical data and variation pattern, what is decided, which output is selected is decided. These are used for load forecasting like back propagation, off-field, Boltzmann machine. Different types of ANN architectures are used. So advantage is ability to learn. So and disadvantage is overfitting or over parameterizing. This is the disadvantage. I will not go in detail. This is different altogether subject for computers. Page, we have to shift to next page. Okay, so univariate method is 7th method. So you have auto-regressive integrated moving average and all. So all these ARMA models are formed. So load demand is dependent on weather and changes in weather pattern. To improve accuracy, what we do, we use univariate. So stationary stochastic process is used in terms of 2 polynomials. So this is called as hourly load demand, which is non-stationary So that's why we use ARMA model. Full form of ARIMA and ARMA are auto-regressive moving average and auto-regressive integrating moving average. So what we do, we write a function. As I told you, this is not in syllabus. Just for your beta 1 TT plus beta 2 HT plus beta 3 WT plus beta 4 RT plus dot 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 plus last is beta n xt plus error. So this is one function where T, H, W are different parameters like temperature, wind, rainfall, and beta is regression coefficient. What happens here? So this beta 1, beta 2, beta 3, beta 4 are nothing but weights. Weights means what? This function will have more value if these weights are more, and when these weights will be more, if you want temperature to be given priority, this beta 1 value will be high. If you want humidity as a priority, this beta 2 value will be high. If you have weather as priority, you will have beta 3 value as high. If you have rainfall, this R stands for rainfall, and so on. This is storm, X is for storm. So all these are nothing but historical addition of historical parameters with what? Your weights. Then similar day method. Next method is similar day method. So what you have to do? You have to have a function is DMC, similar day method consumption is a function. This function is written in terms of what? F of S comma W, and there is a error. What is S and W? S is season or time of day or season, and what is W? W is weather variation. Epsilon is error. So you have to write a different function for this. So similar day method is to find a day in a history that is similar to the forecasted day. So commonly based on day of week or season of year. So this again uses weighted and extrapolation to forecast load. Then we have hierarchical forecasting method. So we use smart grid technologies in that to improve load forecasting. So you know, load pattern and all, demand side management and all. So all that is used, geographical, spatial data, temporal data. So all these hierarchies are imported in your smart grid, and smart grid takes care of your hierarchical forecasting method. And last is your time series method. So time series method is based on assumption that data have constant trend with chosen parameters described by your correlation, trend, seasonal variation. So we are plotting what? Load, demand versus time. This is called as scatter diagram. In time series we plot a scatter diagram and we decide. So it is further divided into freehand method, method of moving average, and least square method. And last method is your, so this was your, I think, ninth method is hierarchical, and 10th method is time series, and 11th is expert system. Time series you have three. First is freehand, then you have moving average, and you have least square method. All these three. Okay. In expert system we have simple moving average and weighted moving average. Last is expert system. In this expert system we have simple moving average, then we have exponential moving average, weighted moving average, and exponential moving average. So this is all about your forecasting. So this question was asked earlier. We have also seen what is your peak load forecasting and reactive power forecasting. So all this completes our first chapter. So we only have some questions which I will take in tutorial. Is it clear? So that's it from for first lecture. Now I will stop here, and I will provide you with some notes on this time series and expert system. You can read it. It's all mathematical part, and there is no numerical asked on this yet. So it's only you have to write short notes if asked in exam. Okay. Thank you.